Good afternoon and welcome to my laboratory. This is a supplement to the last triangle ramp video that I showed. It turns out that this probe was malfunctioning during that video, and that was why we weren't getting the signal that we expected to get from monitoring the MOSFET drain as we drove the demonstration. So what I'm going to do is just basically do it again. We have the F43 function generator set to produce a triangle ramp, and we're going to display that on the top trace of the oscilloscope screen there with 10 volt peak to peak or plus 5 volt, minus 5 volt excursion on that triangle ramp. And then I will be using the offset control to vary the offset, to put in some positive offset in that signal. The baseline is right there on that gradical marker. The channel 2 then will be monitoring the MOSFET drain, which is the low side of the load with respect to the negative rail, using a scope probe that now actually works properly. Okay, we're looking at that again at 5 volts per division, and what we're seeing there, of course, is the supply voltage, which is 12 and a half volts. Okay, so from there we've got 5, 10, about 13 volts indicated on the oscilloscope. And of course, when the MOSFET is off, the voltage at the MOSFET drain with this circuit arrangement will be high. So the troughs in this signal indicate the MOSFET turning on. Okay, and whenever the input voltage is over about 4 volts, that's where the MOSFET is actually turning on. So if I use the trace positioning control to overlap those traces, you can see that the MOSFET is turning on right there at a voltage of about plus 3.5 or 4 volts. Okay, let's put that back where it belongs. Okay, now if there's not enough voltage coming in, I'm going to turn the triangle ramp wave down in amplitude. So now the MOSFET is not switching, the light is off, right? And the drain voltage remains at the battery voltage. Okay, as I increase the triangle amplitude, we see the MOSFET starting to come on. And then if I use the offset control to add a DC offset, we see that the MOSFET stays on longer and longer. The MOSFET is on at the bottom of this trough, right? So longer and longer and longer until with an offset of about 10 volts, the MOSFET is on 100% of the time and the light is shining very brightly. Okay? Now the reason that we were getting that strange display in the previous video was because there's actually something wrong with this scope probe. I was not getting a good contact in there, and we were actually not reading the true value at the MOSFET drain. But we are now. Okay. All right. Thank you for watching.